Okay, so starting with the first one, they give us two coordinates. They say find the halfway point, which is the midpoint, and then it says find the point 3/4 of the distance from P to A. Starting out with the midpoint, you could use the equation. Often people have trouble like remembering equations, so I'm also going to show you it by graphing, because even if you can't remember the equation, a lot of questions you can figure out just by graphing the points. So number one, we're going to plot the coordinates that it tells us to graph. P is at 2, 11. So 2, 11 would be right here, which you probably already have graphed. And then point A is at 4, 3. So here's point A. Then, as precisely as possible, I'm going to connect those two dots. So there's my line segment. It says to find the midpoint. So some of you will be able to just see that the midpoint is right here. And that is at 3, 1, 2, 3, 4, 5, 6, 7. So that's at 3, 7. If for whatever reason it was hard for you to see, or it didn't land at like an intersection of points, so it was like a decimal, you could use the equation. The equation for midpoint. So on your paper, I am going to be collecting this. It is also going to be used as a study guide for you. So make sure that you write down all the work that I'm writing down so you can use it to study for the EOC. So the equation for midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. So as far as your coordinates go, this would be x1, y1, and x2, y2. You're finding the average of the x's by adding them up and dividing by 2, and same for the y's. So plugging in the numbers, 2 plus 4 over 2, and 11 plus 3 over 2. And solve that out. And you get 3, 7, which is the same coordinates that we found by graphing it. So that is the midpoint between the 2 points. The next one is a little bit trickier. We did practice this with the partitioning a line segment. It says find the point 3/4 of the distance from P to A. Now, we already have the halfway point. 3/4 of the way, if we broke this up into 4 parts, 3/4 would be about right here. Now, notice that it doesn't really follow the intersection. Most of the time on standardized testing, it will. In this case, it doesn't. When it doesn't fall at a specific intersection, we are going to have to do the math to figure this out. The way we can do this is by looking at the slope. So from P to A, it is going down 8 units, so down 8. If I was to count this, 1, 2, 3, 4, 5, 6, 7, 8, and then across 2, so positive 2. Now, if I go down 3/4 of the way and 3/4 of the way to the right, I would land on that point. You can maybe even kind of do that in your head. 3/4 of 8 would be 6. So you could go down 6, 3/4 of 2 would be 1.5. But doing the math, and also showing it on our paper so we can use it as a reference, you would go, it's going down -8, and to the right, positive 2. And then 3/4 of that, you can multiply by a fraction. So 3/4 of the way down would be -6, and 3/4 of the way to the right would be 1 1/2. So to find the point 3/4 of the distance from P to A, erasing this here. could count down 6. 1, 2, 3, 4, 5, 6. So go down 6, and then go over 1.5, and we land at this point, which is at 3.5. 1, 2, 3, 4, 5. 3.55. And that is our point 3/4 of the way to A. And then I'm going to write this over here, 3.55. For the EOC, you will have graph paper. You will have to draw your own coordinate plane, so.
And you just find the midpoint between the midpoint and
Oh, that's a good idea too. Yeah, you could find so once you had this midpoint at 3.7, you could find the midpoint between that and A using the same process you did it, the original. Good call, Logan, you could do that. Okay, number 2, it says, given the pre-image A, B, C, as shown, find the coordinates of A, B, and C prime. So we're going to have to find the coordinates A prime, B prime, and C prime. We're reflecting this over the y-axis. When we reflect the shape, we're actually just reflecting each individual point. Is it about the placement? Oh, yes. Yeah, go ahead. So when we reflect this over the y-axis, reflect each point individually, and then the entire shape will be reflected correctly. So A is 2 units to the right, so we need to put A prime 2 units over that line of reflection. So this would be A prime right here. C is 4 units to the right, so we'll do it 4 units across. So this would be C prime here. And then B prime is, if you were to count this, 7 units to the right. So we'll do it 7 units over here. 2, 3, 4, 5, 6, 7. B prime right here. You can connect your points. Just make sure your shape looks exactly the same. It should be the same size and everything. And then you can pull the coordinates from the graph. So -2, 6 for A prime. B prime is at -7, 3. And C prime is at 1, 2, 3, -4, -1. Remember, write down the work. I won't be collecting this today, but I'll be collecting it tomorrow after we do the week 2. Okay, number 3, it says write the translation rule that produced the image from the pre-image shown below. Okay, so a translation rule looks like this. It would be x, y, x plus however far it's moving to the right or left, and then y plus however far it's moving up or down. A translation is a slide. When we look at the translation rule, just identify one point that you want to focus in on. So we'll focus on point A. We have A and A prime. Remember, A is the pre-image. This is the original. And A prime is the image. And that is the new location. Some people have trouble remembering that. You could maybe remember that the one with the prime kind of looks like an eye, and that is the image, which starts with an I. Okay, so to get from A to A prime, we are going to do horizontal change first. So it moves this way from -6 to 2, so that would be +8, and then it moves down -3. And then we can put these in here. So +8, and then it's -3. Normally the translation rule doesn't have plus -3. It would just be written like this. X plus 8 and y minus 3. And this is your answer. number 4, they actually get simpler from here on out. Number 4, it says explain which transformation was used to produce the image from the pre-image shown. So we see A, which is the pre-image. And then here it's showing A prime, B prime, C prime, so this must be the image. So it's saying going from pre-image to image. It's definitely not a reflection, it's not a dilation, it is a rotation. They're rotating it here. So it is a rotation. Remember, rotations go in the counterclockwise direction, so this would be a 90-degree rotation. As far as the rotation rules, you do need to have them memorized, but I don't think it's not that challenging actually to memorize these rotation rules. So write it down right now, rotation rules. The ones that you would need to remember is 90 degrees, 180 degrees, and 270 degrees. Remember, 360 degrees, it would just land on itself. So they would look like this. XY becomes what? XY becomes... The easiest one for me to remember is the 180, which would be negative X, negative Y. Both of them just change sign, become the opposite. Then for 90 degrees, the X and Y switch places and the Y becomes negative. And then for 270, again, X and Y switch places, and this time the X is the one that becomes the opposite sign, or negative. So you need to be able to write this out with, it won't be on a reference sheet or anything, so you'll need to write it out if you have to do a rotation on testing. And number 5, describe a series of reflections that will map trapezoid WXYZ back onto the original pre-image. This is subjective answer. There's more than one correct answer for this. You could simply just reflect it over the x-axis and then reflect it again onto itself. You could also reflect it like all the way around. So as our sample answer, you may have put something different that is also correct, but we're going to reflect it over the y. That would put it here. Doesn't have to be perfect. And then reflect it over the x, which would put it here. Then we'll reflect it over the y again. And then reflect it back onto itself. So then reflect over x-axis. Again, there's more than one correct answer for that, but that is one of them. Okay. So the other side we aren't going to do for tomorrow, so just put it in your folder. That way you can take it out for tomorrow. If you'd like to look over the questions for tomorrow, I encourage you to do that. That way you get some time to think about it before we just go over it. I'm going to stop my recording now.